Hi there. So in this video, we are going to take a look at our lesson 1 notes for the polynomial expressions unit. So let's start with some definitions. So we have these along the side, which is nice that as we go through the unit, when I'm using these terms, you understand what we're referring to. Speaking of terms, a term is a number and or variables multiplied together. You will see these separated by plus and minus signs. Okay, an example would be 4x is a term, or 3xy squared is a term, or 2 is a term. Okay, a monomial, you'll see this prefix of mono, which means one, so one term. Again, all of these are one term. So 4x, 3xy squared, 2. There's others, but I'm just emphasizing the point that a term is called a monomial. A binomial, that means it's 2 terms. And like I said earlier, they're separated by plus and minus signs. So an example would be something like 5a plus 7b. That would be a binomial. A trinomial is 3 terms. Okay, an example would be 8x squared minus 5x plus 1. So 3 terms, 1, 2, 3. And then after that, we just got lazy and we call the rest polynomials. Even the binomial, trinomials, those are called polynomials as well. Even a monomial. Oh, what am I writing? Sorry. This is one or more terms. All right, and all of the above are examples, but here's one, 12x to the third minus 10x squared plus 11x minus 4. Okay, and then we have like terms, and they are terms that have exactly the same variables. Terms with exactly the same variables. And when I say that the variables are the same, that includes their exponents. So like x and x squared are not like terms. So for instance, if I have the term 5x squared y to the third, that would be a like term with 3x squared y to the third. So everything after this coefficient has to be identical. Okay, so in this lesson, we're also going to focus on adding and subtracting polynomials. So to add polynomials, you're just going to add like terms. Add the coefficients of like terms. Okay, so when you're adding like terms or subtracting, the variable part will not change, just the coefficient part. So here, these parentheses aren't really necessary. We're just seeing that we're adding a binomial plus a binomial. And I want you to remember that right in here, there's an invisible 1. So if you want to write that in, you can. So I see that we have 2x squared and a 7x squared. When I add those, we get 9x squared. And then the variables that just have an x, 5x minus 1x is a positive 4x. So that's our answer there. For this one again, because it's addition, we don't really need the parentheses, so I'm just gonna ignore those. We will with subtraction. So adding our like terms, 7x squared plus 3x squared is 10x squared. Then this negative 4x, that's the only term like that. So minus 4x. And then 2 minus 6 is negative 4. So that's our answer. Now, if you have colored pencils or something, it might be nice to color code them with your like terms. Okay, example 3, again, same thing. We have addition between the quantities, between the parentheses, so we can just ignore the parentheses. So 3a squared and 8a squared would give us 11a squared. Here we have a 1a minus 5a is negative 4a. And then lastly, let's see here, negative 2 plus 4 is positive 2. So that's our answer. And this is our last example with just adding. So 4m squared, that's the only m squared, so nothing happens there. Negative 6m minus 4m is negative 10m. And then finally, negative 9 plus 8 is negative 1. Okay, so that's that page. Let's move on to our second page of notes here. And we're going to start by subtracting polynomials. So what we want to do that's different here is we want to rewrite each expression without the parentheses, but we're distributing a negative 1 as needed. So let me write that down. Rewrite each expression without parentheses. Distribute negative 1 as needed. And then add like terms. Okay. And if you need more time to write, just pause me. So looking at example 5, there's an invisible 1 right there again. So that's the negative 1 I have to distribute. In front of this set of parentheses, there's an invisible positive 1, but distributing that wouldn't change anything anyway. So what we get when we do that is 4b minus 8. Then I'm going to distribute this negative 1. And when I do, I get minus 4b. And then here, negative times negative is positive. Okay, so your signs are going to change. Combining like terms, 4b minus 4b cancels. They cancel each other out, and we get negative 8 plus 9, which is 1. So the answer here is simply 1. Okay, let's rewrite this one. Positive in front, so nothing will change when I distribute a positive 1. So 8r squared minus 3r plus 9. And now I'll distribute this negative 1. Remember, there's an invisible 1 right here. So when I do that, gives me a plus 7r squared minus 1r plus 7. All right, combining like terms. Now, when I combine like terms, I try to start with the highest exponent. So see, we have r squareds. That's usually where I'll start. That way it's in standard form. So 8r squared plus 7r squared, 15r squared. Negative 3r minus 1r is negative 4r. And then 9 plus 7 is positive 16. All right. Next example. Again, I'm going to rewrite it, distributing negative 1s as needed. So here, it's not needed. So negative 7k plus 8. Here it is. Negative, so that would give me minus k squared plus 9. And then for my last quantity, plus 8k squared plus 5. Combining like terms, again, I'm starting with the highest exponent. That's not It won't be wrong if you don't do that, but it just won't be standard. All right, so negative 1k squared plus 8k squared is 7k squared. Negative 7k, that's it, negative 7k. I couldn't believe it. 8 plus 9 plus 5 is 22, positive 22, so we'll get plus 22. All right, and last example here. This first quantity won't change. 8z squared plus 4z. I like to put the little lines through my z's, that way I don't accidentally think they're 2's later on. Okay, distribute this negative 1, so we get plus 5z squared minus 1z minus 4. Combining like terms, 8z squared plus 5z squared is 13z squared. 4z minus 1z is positive 3z, and then there's still a minus 4 hanging out. Okay, so those are my examples with subtracting polynomials. And now, our last 4 examples, we're just going to combine. When do we distribute? When don't we? When do the signs change? When don't they? Let's make sure we're okay with that. I'm going to rewrite it, and I'm looking in front of each quantity to decide if I have to distribute. So here there's a positive 1, so when I distribute, nothing changes. Distribute a negative 1, so our signs will change, plus 2x minus 7. Here, distribute a positive 1, so nothing changes, minus 5x minus 4. And then finally, we combine like terms. 9x minus 5x, oh, I missed this one, plus 2x is 6x. Negative 5 minus 7 minus 4 is negative 16. Okay, example 10. 3d squared plus 3. Now here we have a plus sign, so nothing changes. Plus 6d squared minus 7d. And then here we have a minus sign, so we distribute a negative 1. So it will be minus 6d plus 2. Combine like terms. 3d squared plus 6d squared is 9d squared. Negative 7d minus 6d is negative or minus 13d. And then 3 plus 2 is a positive 5. Okay. 4j squared minus 8j plus sign, so nothing changes, plus 2j squared minus 1j. Here's a negative, or a minus, I should say, so we're going to distribute a negative 1. So minus 6j squared plus 9j. Combining like terms, 4j squared plus 2j squared minus 6j squared cancels. Because 4 plus 2 minus 6 is 0. And then negative 8j minus 1j plus 9j also cancels. So everything canceled, our answer is 0. Last one. 8n minus 4k, distribute the negative 1, plus 6n minus 6k. Here we're distributing a positive 1, so nothing changes, minus 7n minus k. Now combining like terms, this one we have different variables. So typically we would go in alphabetical order in that case. So negative 4k minus 6k minus 1k is negative 11k. If you don't go in alphabetical order, you're not wrong, okay? 8n plus 6n minus 7n is positive 7n. Okay, so those are the notes. Give the practice problems a try, and that was lesson 1 of this unit.